Anyway, we'll continue with file handling. Why files and things like that we've already seen. See, we looked at so many methods for files, right? That is, you can get the name of the file, parent, path, and things like that. And I think I stopped here. We can get the list of files in a directory. What it returns is a string, an array of strings. You can also get list of files returned as a file itself. So we'll be looking at these two methods, and then we'll directly move to IO streams. We'll take a look at IO streams. We'll refresh our concepts on IO streams again. So we'll take a look at how to return a list of names in a directory, list of all the folders and things like that. So let's go and work on this. Say, let me take up my own workspace here. Say, when you take a look at this, I have a lot of folders and files here. Suppose I want to return the names of all these folders and files from my directory. What I can do is I can create a file object for this directory first. So you create a file object for this directory, and then you give the path, okay, where this directory is. And then what you're going to do is just call this function obj.list. So this one actually returns a array of strings. So it says string names is an array. So it returns an array of names. What are these names? The names of all these files and folders in my directory. So from here, what you're going to get is, how will you print all the names from this array? You can use an enhanced for loop. For every string s in names, I can go and print all the strings available. So let me go and check this, run this one out. So you see all the files and folder names are getting printed here. You can also get back, you can use this another method, that is list files, which will return a file object itself back for everything. So what we'll do is we'll go and do list files. So instead of using list, I'll use dot list files. So this one actually returns what? Object of type file. So it's an array, right? Again, so it's going to return an array of files. So you're going to have this file name object.list file. So it's going to have a list of objects of type file in your array. So what you're going to print here is, you will print for every file s in the file array, we'll do s dot get name. Get name will just print the name of that particular file. So what is getting returned is an object of type file, an array of objects of type file. So let's go and run this one out. So when you see, you have dot get name for all your file objects that are getting written from that directory. So like this, you can use lot of other methods on your file. So even before using a file, you can model a file object. That's what we have learned. Next thing is, we went into the seminar on IO streams. What is an stream? What is a stream? I mean, in computer science terms, mother gave us the definition that it's something that flows in some order. So what is a stream? Stream is nothing but sequence of data. Sequence of data or sequence of bytes. So you can call stream is nothing but sequence of data. When I mean IO stream, input output stream, I'm going to read data from certain input sources. And output, I'm going to write sequence of data to some output sources. That's it. So we are going to read some sequence of data from an input source. We can write a sequence of data to an output source. So that becomes input output stream. So let's go and take a look at our programs that we write. Normally we read inputs for our programs, right? So from where we get inputs? From our keyboard. So from the keyboard, you're typing some characters, you're typing some numbers. So you're getting some sequence of data, some stream of data coming in, and your program somehow reads that from the keyboard. For this, a Java program uses a set of inbuilt classes, and also it talks to the Windows native API methods to read the data from your keyboard. And you also write data to your console, your screen, right? So data, again, what is getting written? Sequence of data. Sequence of data gets written. It's not only from keyboard and console. You can also read data from a file, from a text file, from a binary file. You can read data. Again, what you will read? You will read sequence of data. You can also read data from a database. You can read data directly using a network connection. So you can read sequence of data from any of the input sources. You can also write sequence of data to a file. You can write to a text file, to a binary file. You can write data, insert data into a database. You can throw some data to some other system on the network. So you can write data. So everything is written as bytes, written as sequence of bytes. That's it. So everything is just zeros and ones going outside and zeros and ones coming out inside. So Java, when you talk about Java offers us, yeah, the next question we can have is how we read data from all these sources. I said sequence of data, right? How we read data from all these sources. We can read data as 8-bit bytes. Say when you talk about file, you can read data in 8-bit bytes like this. So you have 8 bits read at a time. So you call that to be a byte, right? So you, from your text file, you can read data in bytes, like 8 bits at a time. So like that, you have to scan through the entire file to read every 8 bits of data in your file. So that is one way of reading. Another way of reading is we can read data as characters. So what do you mean by characters? It can be either, I have missed one thing here, ANSI standard, ASCII standard, or Unicode characters. So what are these characters? What do you mean by a character? Character is nothing but a sequence of bytes encoded to some symbol, right? Say for instance, I have this ASCII chart. In that, if I say H, H is encoded to 104, which can be represented in some binary format. So you have a mapping there. So ultimately what you can do is you can read a sequence of bytes and then you can map it to a character. So I can have some classes that can read bytes, convert it to a character and give me. I can have a class which can write bytes and then it converts it to a character before writing it to the standard output. So you can read in as characters. So when you are reading in as characters, you are reading in bytes, whereas it is converting it to a character for you, so that you get a character as an input. When you read in as normally raw data, you will get only zeros and ones. But when you read in as a character, you will get some encoded value for a character. That's it. So you should know what are the different encoding standards we have: ANSI, ASCII, Unicode. And in Unicode we have UTF-8 and UTF-16. We'll come to all these things later on. Only thing is, we can read in as characters. We can read in as primitive data types. Say I can read an integer, a boolean value. I can read an character string from my input. Reading in it as a primitive data type is also possible. And we can read objects. Say I create an object, I can write an object out to an output source. I can read a set of bytes and convert it to an input object definition. So it's called serialization and deserialization of objects. So what do you mean by deserialization? I can get some stream of bytes, convert it to an input object representation. So when you want to read data, you can read it as raw bytes. You have some classes which enable you to read it as characters. You have some classes which enable you to read data as primitive data types. You have some classes which can enable you to read data as objects. So when you read that set of bytes, it gets converted to an object for you. So all these things you can do. And there are so many other classes for so many other different things. We only learn these 4 important things from our Java programming perspective. Okay. So first thing that we look at is how can we read data as 8-bit bytes from our input source. Okay. How to read data as bytes. So what you are going to read, you are going to get something like this. Whenever you read a data, you are going to get some byte, 8-bit bytes. Say this is one 8-bit. So like this, you are going to read data as byte by byte. You're going to read data byte by byte. So how to read data as bytes? When you want to read data as bytes, Java gives us a set of classes that we have to use when you are reading data as 8-bit bytes. The topmost class is the input stream. And this class has got so many other classes that extend it. So here file input stream is an input stream. So whenever you're going to read data as bytes, you're going to use objects of input stream or its extended classes to read data as bytes. And we have so many different classes extending input stream. Why so? Because each class serves a purpose. If you want to read bytes of data from a file, input text file, I'll use file input stream. If I'm going to read directly data from my system console, I mean keyboard, what we do system.in, right, to read data from the keyboard. Then I'm going to create an instance of input stream and then read data. If I want to read from a file, I'll create an instance of file input stream. I'll create an object of file input stream and we'll read data. Likewise, you have byte array input stream, filter input stream, buffered input stream, data input stream, object input stream. So we learn all these things after some time. But now our focus will be on how to read data from a file. So file input stream will be used for reading data in bytes from a file. What is this input stream? When you want to read data from the keyboard directly, you create an object of input stream and you read it. So for instance, let me go to the system class. How you read input from the keyboard? You always do system.in, right, in the scanner class. So you just give system, and then when you take a look at this system definition, when you go and take a look at this input stream, in is nothing but an object of type input stream. So it automatically uses an object of type input stream to read the data from your keyboard. Whereas when you want to read data from your file, it is file input stream. Okay, let's go and look at how to read data in bytes from a file. We are going to use an input text file and read data in bytes, 8-bit bytes from the file. So for that, even before reading data, what are the two things? First thing is you have to create an object for that file. You used file, new file, and you create an object. And then you're going to create an instance of file input stream. How do you create an instance of file input stream? You have two ways. One is you pass that file object and then you create an instance of the file input stream class. So that this will read sequence of bytes from that file. Or else you can give these text name, path can be a string too. So you can just give the path for your file as a string. So the input stream will read 8-bit bytes from your input file. So first thing, we'll say I want to read some data from my file. Let me take this file Satish, which is already there. It has got this text hello. I want to read data from this file. So what I will do is, first I will go and create an object for this. Let me go and create an object for this file. So let me delete everything here. How will you create an object? So you go and create a new instance of file. That is file. I can say obj is equal to new file. And what is that file I'm going to use? Satish.txt. So this is the file I'm going to use. I've created this. Next thing is I want to read 8-bit bytes from here. So I'll go and create an instance of file input stream class. So how will I create an instance of file input stream class? So it's a file input stream class. And then you just give some name, fin. So that's the name, and then you give the what this input stream class gets, the file object. So you just pass the file object here. Okay. So once when your stream class is ready, you can go and use the methods of your file input stream class to read in bytes. That's it, bytes from the file. So what are the methods in your file input stream class? Read. So read will read 1 byte from the file, and read byte array B, this is an array of bytes. So when you use this function, you'll read an array of bytes at a stretch from the file. So you know what is this byte data type, right? It denotes 1 byte. It's an integer data type, but it denotes 1 byte in the file. So you can also have an offset and length defined while you're reading an array of bytes. We'll see all these things with some practical examples. We'll take a look at the first thing in read. What read does, reads one byte from the file. So what we'll do is very easy. One important thing is when you're working with files, you should always put that in a try catch, handle exceptions, because file not found exception, user privilege exception, all these kinds of exceptions can occur on the file. So always enclose that with try catch. But here, how will you read? You just give the instance name fin dot read, the method name. So this will read one byte. So we'll just read it in data. In data is equal to fin dot read, whatever that is getting read. And what we'll do is we'll print the data out. Sys out will print data. So what do you think should be the data here? Say what I have in my file, Satish file, I have HELLO. So what do you think should be the output now? I'm just reading one byte from that file. What do you think should be the output? So let me go and execute this. Let's look at the output. Let's understand it. It says it's 104. There is an H in the file, but we are getting 104 here. What is this? Yeah. See, 104 is nothing but an encoded value for your symbol H. So when you take a look at this particular text file I have used, this text file is, when I say H, this H should be stored in some kind of a number so that you can store it internally, right? So what is this file? This file is actually, when I save file as, you can see the standard for encoding this file is encoding. You can see this encoding option here, ANSI. So it uses ANSI standard for encoding. ANSI is a Windows based standard. So what it does is it takes every value and encodes it to be 8 bits. Let it be a character or anything. So Windows uses an 8-bit encoding standard. So that is an extension of your ASCII standard. ASCII uses 7 bits, Windows uses 8 bits. So here you can go and look at the ASCII chart. I mean the ANSI character set. So when you take a look at the ANSI character set, go online, search for ANSI character set, ANSI. So you can see for a small h, the value, encoded value is 104. So when you are reading in as 8-bit bytes, it's just reading in 8 bits corresponding to a character, because characters in Windows are stored using ANSI standard. So that's why we are getting 8 bits here. Okay. So you can very well convert that to a character and display. How will you convert this to a character and display? You can just do character and then display. So now it gets converted back to H. So what you're reading here is one 8-bit byte you have read. That's it. That is H. So you can encode 104 using 8 bits, right? Binary of 104 can be accomplished within 8 bits. That's what I mean to say here. So this is done. Say if I want to read all the data in my file, I have just read H, I want to print all the data in my file. What I can do is, I can run a while loop till the end of the file. The end of the file marker is a -1. So what I'm going to do is, I'm going to use a while loop and perform this. So while we can read data is equal to fin.read. So this method, until it, this entire thing returns a -1. Until it returns a -1, I'm just going to read every data in that as 8 bits each time. So let me print data. So this should actually print HELLO, right? So HELLO. So each one is an 8-bit representation of the data that's coming in. So you want to convert that to character and show it to the user, you can just put character and then you see, you run this one. So what is this H? It is actually a text file H. What is that text file? In what standard it is encoded? ANSI standard, because I'm using a Windows system. It's an 8-bit system. Okay. So what other methods we have seen? You now understood how to read data in bits, right? So what other methods you have seen? Read an array of bytes. So I can declare a byte array and say I want to read all these four bytes together at one instance. So how can I do that is I can just go and say let me delete this, let me create an byte array, byte b is equal to new byte, and say I love 4 bytes of data. Now how will I read data here? Fn dot read. Now I have to pass this byte array b. That's it. So it's going to read 4 bytes and move it to my byte array. So what do you mean by 4 bytes? HELL will be the 4 bytes. So if I want to print everything in my byte array, how will I print? For every byte k in my byte array b, what I'm going to do? Use the enhanced for loop and then you print all the bytes. So if you're going to do this, you see 4 bytes was read, it was moved to the byte array. And then I was printing everything from the byte array. So there's a small variation to fin.read and fin.read of b. b is a byte array there. I can also enforce something. So inside my byte array, I can start writing from my say first location, and I can write only 2 locations. I can do that. So I can read from my file. Say I can write h in my second location in my byte array, and then third location in my byte array. H, E alone I can write. So let me go and show that variation. Say you see here there is a byte array, right? I give int offset from where I should start writing in my byte array, and then length. So how many fields I should write? So start writing from one index in byte array, write 2 characters or 2 bytes. It's not a character, right? So let's go and check that out. So we'll have byte array. We'll start writing from offset 1, and then we'll have 2 bytes from the input. Say it reads H and E, 2 bytes starting from 1 in your byte array. Now let me go and run this one. So it's 0, we're not writing anything in the byte array. We start from writing in index 1, and then we run up till 1 and 2. 2 is the length. And index 4, we are not writing anything. So we can give an offset where we should write in the byte array and how many values we have to write. So like that, if you understand this, most of the classes repeat this method again and again. There's one more thing, available. Available will return you how many number of bytes of data is remaining in the file for reading. Say if I read in 2 bytes, then without those 2 bytes, the remaining data that's available will be shown to the user. Close, very important thing. Whenever you open a stream, say you create an object of input stream or output stream, you have to very important step is you should go and say I finished reading in data from the file. What I should do? I should go and fn dot close. Only when you close this, other programs can go and access this file and start creating a stream and reading data from that file. So before doing anything else, you have to close the file. So in exception handling, I told you, right, we have a try catch block, and in the finally you have to close all your file connections. Either an interrupt occurs or an file, the program executes successfully. Finally, you have to close the stream so that other programs can access the file. So normally how that will be, I'll just show you very quickly. Try, and then you'll have this entire thing inside a catch block, right? Catch, you can find file not found exception, and then you'll have some methods here. We can just print m dot print stack trace. Finally, you learned about this finally block, right? Finally, you're going to have fin dot close in your finally block. So any files or any database connections, anything you have to close them. So is that clear? So we have just looked at the first way, how to read 8 bits of data from your file in bits. So we have seen all these things, reading a byte from the input file, reading all bytes till the end of the file, displaying the integers as characters, reading an array of bytes from the input source, reading an array of bytes specifying offset and length. We have done all these things. Very easy, it's not so difficult. We already add inputs. Writing data as bytes to the output. Say we have read data from the file. If I want to write data in bytes to the output, what's the, say Java offers us a set of classes. Output stream for writing any data to your output. See, normally this is used for writing data in the raw data format, like in bits and bytes. So that is output stream class. So file output stream is used when you're going to write data as bytes. So every byte will have 8 bits, right? So you're going to write 8 bit, 8 bit, 8 bit like that. So you're going to use file output stream. You have other output streams, filter output stream, and then you have this print stream, right? This is extending our output stream. So you do the system.out class. System.out, where we use system.out? System.out.println. So when we say out, we are using an object of type output stream. So you can just go and check the system class. What is this out? Is this an out? You see, it's an object of type print stream. Print stream is nothing but an extension of your output stream. So this hierarchy is only a small number of classes I have shown. Say you want to write sequence of bytes to any output, say console or file, you're going to go and take one of the classes accordingly and write. Print stream is used for writing to the console, whereas file output stream is used for writing bytes to the file. Likewise, you have buffered output stream for writing it to a buffer, because directly working in a file will be, sometimes there can be an IO constraint. So you can write to a buffer, and the buffer is full, you will flush it out. So like that, you have a data output stream, object output stream. So we'll be looking at some of these streams in the coming classes. So let's go and write some data to our output file. We'll create a file and write some data. Say, let me check. There is SAT, there is no file name by SAT here. So I'll just create a file name by SAT and write some data in it. Very simple, the same process. I'm not going to repeat much of the functions we have already seen. So you create a file object. Say I want to write to sat.text. If the file is not there, it will create it for you. So next, what you have to do, you have to use file output stream. File output stream fout is equal to new file output stream. So file output stream also uses two constructors. I know it has three constructors. We'll look at two constructors. One thing it uses the object of type file. So you can directly pass obj here. Another constructor uses a string. So you can just give the path name to your file as a string here. So we'll use the file object that we have created. Same way like how you used input stream. Now let's go and take a look at this. So these are the constructors we have just seen. Now we created an instance of file output stream, and they say one more important thing. If a file, say I give sat.text, right? Say whether a file will be created or not depends on the platform, underlying platform. It depends on the system or the OS you are using. So you cannot say always a new file will be created. But for us in Windows, it creates a new file. So again, the same thing, instead of reading, we can write one single byte to the file. You can write an array of bytes using byte array. You can say from my byte array, start from location 1, take 3 positions, and then write all those 3 positions to my file. So instead of reading and storing it in the byte array, now we are writing it into the file from the byte array. That's it. It's the reverse. But I just show you how to write one byte to a file, and then we'll go to our next concept. So how will you write? You just give FileOutputStream and then you give 104 now. So when I use FileOutputWrite and 104 I give, see it is writing to a text file. Somehow this 104 should be converted to a character, because it's a text file, everything is a character there. So what character encoding standard is going to follow? The Windows standard of ANSI. So when I give 104, that will be converted as H and stored in your file. So let's go and run this one. So you're going to, if I want to read the data again from this file, how will I read data? First thing you have to do is FO.close. I will close the stream that I opened for writing. Then I will create an object of type FileInputStream. So FileInputStream, and then fin is equal to new FileInputStream. So, and then you give, this is the file I'm going to read from, right? And then you'll have this data coming in. Int data is equal to fn dot read. So you're going to read that byte that we have written, and then we'll do a sysout, and then we'll print the data to the user. So what is that data? It's a character. We'll convert that to a character and print. Okay. So we are writing 104 to our file that is not existing. We are reading and we are printing what is that. Let's check what is the output here. H. So we have read and we have written H. We have read H from the file. So it uses by default the system specific coding standards for writing it to a text file. Okay. How to read characters from the input? So far we are reading only data as bytes. Say I want characters to be read. Only thing is it uses that input stream, and on that we have another class that converts that input stream to characters and gives you back. See, there are variations to this. When I talk about a character, there are certain variations to this. I'll try to explain my best. How to read inputs. So when you're trying to read characters from a text file, say you are having a text file, obviously these are all characters. So when you're reading a text file, don't go with the file input stream, you go with the file reader. That's what you're seeing here. So whenever you're trying to read characters from an input source, the set of classes that help us is the reader class and inputs reader, buffer reader, character array reader, filter reader, and file reader. We are very much focused on text files here. So text files will be using file reader. So you're reading a text file, so obviously you have to use a file reader. File reader extends a reader class. Should I really read it as byte by byte and convert it into characters and show? It's up to you, but it's some extra work. Right? You're using a text file, so normally you'll read it using the these set of classes. So why we use that stream? When you're working with a binary file, everything is on zeros and ones. So you can directly go and use an input-output stream to read and write from. Okay. So now we look at what is this file reader class. What is the use of file reader? Convenience class for reading character files. So you have a text file, you use file reader. File reader is meant for reading streams of characters. It assumes the default encoding to be appropriate. See again, when file reader reads your text file, it knows the default 8-bit ANSI encoding standard has been used on the Windows system. So it will convert your characters, anything, using ANSI standard. So you'll get the character values using ANSI standard here. For streams of raw bytes, consider using file input stream for raw bytes. So how will you create a file reader class? Again, the same thing repeats. You pass the object of the file, or you give the path name, a text containing the path. So what are the methods that will help us read characters? You can see int read. Say this one again reads one character from the file, but it returns as an integer value. Again, we are going to get 104 if it is h inside the file. The next method that it offers us is you can read characters from your file and store it to a character array. Directly you can store whatever that's coming in, you can store it to a character array, and you're going to use this particular function. Instead of a byte array, now it's a character array. Likewise, in the character array, you can specify offset and length from where you have to store it. So here you're working with characters. That's what we mean, not bytes. And you also have a close. Either it is input stream, output stream, reader, writer, you have a close method. So what we'll do is we'll go and read characters directly. Oh God, I just forgot of finishing so much today, but fine. So we'll just create an file reader instance. Fn is equal to new file reader. And then you pass this object obj. Say when you're working with text files, normally use file reader automatically. So then you do fn.read. So this will return as an integer value. Though we say it's a character, it returns as an integer value. So it uses the default character encoding scheme for your system, and returns the value. So we just go and do sysout, and then we just print data here. So what it should read that H and print it out for us. So it should be 104 again. What it is actually reading, an ANSI standard character. You can ask me, well, we did the same thing in our input stream, right? We got 104. Why we should do this? You can also use the reader class for reading an Unicode UTF-8 or UTF-16 encoded characters too. When you talk about ANSI standard, it's just 1 byte. When you talk about UTF-16, it takes 2 bytes. Say you want to encode some Greek or Latin characters, it will be of 16 bytes in length. So you cannot use your input stream and just read 8 bytes, it will give you a wrong value. So you have to use the reader class, not FileReader. We'll be using another variation of that to read 16 byte UTF-16 encoded characters. You know what is this Unicode, right? See, ASCII used only 7 bits, so it was only enough for encoding English and some normal characters. Whereas you want to encode Latin, Russian, French, you had more symbols. So 7 bits you had 0 to 127, whereas you needed more number of space, right? So they went in for 8 bits, that is UTF-8. Unicode 8 takes 8 bits, extended ASCII. When you talk about UTF-16, instead of using 7 bits, they went in for 16 bits so that you can have large amount of space to encode all the characters on this globe. So Java uses Unicode. So it can read a character, it can be actually 16 bits in length. For now, FileReader actually uses the default ANSI standard for your platform and it reads, so it's working fine. But you want to read an Unicode, you want to use a variation of the reader class and try it out. So I'll teach that in the next class. But is this clear how to read in data using the FileReader?